Today we've crammed in this. We can only really do one CB repair a week, but a question has arisen as to how you take the Realistic 1010 apart. So I knew we had the service manual for these. When I did this before, and I'm not going to look back on the previous video for the 1010, I don't know whether I used the service manual because I probably couldn't find it. So what I've done, this is the factory original microphone. This is the factory original service manual, which cost me £16.99 at the time. And what I have done, when I just zoom out a bit, whoops, not that much. I've just spent 2 hours today scanning this, and of course it was it's thick stapled, so I haven't got a thick stapler, so I've had to spiral bind it. So it is a photocopy, but it's the factory original. So this is how it was presented, but it does have an A3 circuit diagram, which I've not been able to do. We do have an A3 printer, but it's not compatible with anything beyond Windows 98, which is alright for when I'm doing the hymns and things, but it's a different computer we use for this. So I've put that back together and I've produced this A4 double-sided version, and it means that I can actually put these together for people for a fee. And what I've done is to scan the circuit diagram as best I can, a bit bigger than A3, and then drop it down to A3. So most of it's on that page, and then we split it over 2 pages what's left. So it's therefore got 3 circuit diagrams. So this was made in Japan originally, printed in Japan, and this is a cleaned up, more legible copy than my original photocopy. So with this information, this is my own, been on the shelf getting dusty, Realistic 1010. We actually had 3 of these, and believe it or not, people used to hire these from us. So shouldn't have any corrosion. As I say, I've owned this from new. No, you know, it's pretty spot on. There's nothing wrong with it, and we're going to go through it just for the sake of the video. And the first problem has arisen is, how do you get into it? Well, the service manual doesn't actually tell you that, so we're going to have to play this by ear, and we're going to take out those 2 bottom screws for a start. And then we're going to take out that screw and back. I would have thought the front comes off, but I may be wrong. No. Oh, we've got 2 more screws inside the battery compartment. Now remember, these sets are CEPT only, so they're an excellent set. They're 3.3 watts, 40 channels, CEPT FM only. 1991 from GRE for Tandies. But to me, CEPT is totally useless here. Now the front doesn't come off this one. What's now holding it? I'll just have a look at the... Although there isn't dismantling instructions, there is an exploded diagram. So we can see we've got the 1, 2, the 2 there. I wonder how I dismantled the last one. not a screw under my Dymo label, is there? Don't need to have that on anymore anyway. I wonder if there's some clips. Where's my big screwdriver? Yes. So you saw that. So halfway along it's got clips. Now the next thing we need to do, of course, is to take the front off. So it's my set, so I can see whether it's got clips. No. So it's not clips there, so we're going to have to take some screws out. So I'm going to probably end up taking some wrong screws out, so watch what I take out and then watch what I have to put back again. So we've had two short ones, and here's the longer one, which I may be taking out in error, so we don't know yet. I don't even remember doing one of these, but I must have done one of these. So we're going to need to take the aerial out. I can't get it out with that screwdriver. Take out the aerial. That reveals that screw. So far, 1, 2, 3, 4, 5. Let's see whether that releases the front or whether I've taken too many. It's released the front. For those of you who've seen Monty Python's Life of Brian, we wees Wadwick. Well, we wees the front. Now the next question is, how many screws should I have taken out? So let's count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's what you take out. So it's all 5. I didn't get any wrong. So that's what we're left with. And now the phone's ringing. So just to show you, I've taken the display board out. So you've got an LC7131 synthesizer just there. Didn't say I could put that back, and it's got a clever chip on the back. So test point 1 for the VCO. So with a RCA stroke Motorola adapter, we'll plug that into the extension speaker extension aerial socket. we're going to need to connect the power up to the radio, which is 12.5 volts maximum. This is a 3.3 watt radio. It's not a 4 watt radio. And what does the service manual say is acceptable? It says 2.8 watts is the minimum acceptable transmit power output. So we'll connect this up to our power supply, which is set to that voltage. Switch the radio on. Put it on channel 20. Oh, we'll probably hang on. We'll follow the instructions here. Right. Yep. So, Vco Alignment. Select channel 1. Today we've not got the normal multimeter, we're going to use the little one. And test point 1, if I change my glasses. So, moving on to the VCO for a start, we need test point 4. Test point 4 is just there, and what we're looking for is 2.5 volts plus or minus 0.1, and we're going to adjust it slightly out even though it's never been touched. We need to just get that to 2.5. This is on channel 1, and then I've got to change it to channel, is it? Just make sure we are on receive. Yes. Now we need to go to channel 40. These are both on receive. Now, how do I know which way is channel 40? Now we haven't got a display. Well, I think what we'll do is we go one click. If there's a big voltage difference, like there, we must be on channel 40. So if I go back one click, we're at 2.5 volts. If I go forwards one click, we're on 2.53, 2.5. So that must be channel 2, and that must be channel 40. So we need to check that the voltage between 3.5 and 4.5, and it's spot on, it's bang on the money, that. And now we go straight into transmit, and we need to check it's between 4.5 and 6 volts. So just make sure the test set's geared up for that. Yep, it is. And if I can find a transmit switch, it corresponds with the second button down. That's the first one. And it's 5.3 volts. And they say it wants to be between 4.5 and 6. So we've successfully set that up with test point 4. I think before we do anything else, we'll switch the radio off and put the display back. Go to see what we're doing then. Making sure that both the headers go into the pins, just like that. Switch back on. And now we'll go to channel 20. Now they want you to put it on frequency next. I think we'll put the meter away, that's done with. So we'll just look at the frequency counter. Going to transmit, and we want 27205. So you could say that's as near as damn it. We'll just TC1 to 27. Use the other trimmer. Whoa. ever regret ever changing where it was? I think that's as near as damn it. We'll do 20506. So that's where we've got off that first page. Oh, we've only got another we're a third of the way through by the looks of it. So they're going to do transmit first, which is exactly the way I was trained and is sensible. And what we're going to do is go back to that meter. We're on the 3 watt scale, and right now, are we on low power? Yes, we are. We're on high power. I'll tell you what, it's doing 3.1 watts. So transformer 7, 8, 9 and 10. So I'll just get myself into position. 7 is under the display, 8, 9 and 10. And then L7 and L10. And L10 is there. So I'm not going to do the one under the display. I could pop it back out again, but I really don't need to for this demonstration. So we'll start with 8. 9, 10, L7, L10. And we're still at 3.1 watts, which is exactly what... When I bought this in 91, I would have done this. But it's a very long time. It's, you know, it's 30 years ago, isn't it? And then what do we do? That's it. So VR3, which I will think is going to be that one. It is. We're going to set for the 3.3 watts if we can. So it'll actually do 4 on this sample, but we're going to set it to the 3.3 as prescribed. For the extra power output and the tiny range difference, the battery gobbling would be ridiculous, and this is why a lot of handhelds are in this 3.2 watt range. If you remember the 1001, the 1005, they say 4 watts on them, but they're 3.5 watt radios. And they're getting that current consumption down to something like 750 milliamps instead of 1.2 amps for another 50 yards range. So that's VR3 done. High-low power, we'll switch to low power. Let's see what it says. And they say they want it to be between 0.4 and 0.8. And right now we are at 0.45. So that's bang on the money. We'll go back to high power. Right, we may have to... The deviation is a bit of a swine to set up. I think we'd better follow the instructions. I'll get the meter back. Because if you get one of these and it's been fiddled with, and they haven't got the manual, they will get this round their neck. So VR2 is there, and what we have to do is to connect our test meter to test point 2. I had a brainwave just now. God, that makes a change, you'll say. I was looking for an old power mic, because we just put them in the bin. The trouble now is the leads are so hard to come by that we may well recover leads off, or serviceable leads off what we would deem to be scrap mics. So any radio that comes in with a power mic, well, it just goes in the bin. So, amongst the stash of kind of questionable mics, I found a proper Tandy. It's been through the wars, hasn't it? And it says RS on it, which it wouldn't do in this country. So this probably came off an AM set, and I've just bought this in a batch of stuff, but the plug's gone AWOL. So what we'll do, we'll put one of the nice Rian metal plugs on. And this is going to serve two purposes. We're going to be setting up this voltage using an AF signal source. And what we're going to do, I was going to get a curly lead, and probably a die-cast box, put a BNC on the die-cast box, and that would be our input, and probably even put a toggle switch on, so that we'd got this lock it in to transmit while we do the measurements type of thing. But now I've found this microphone, once I've wired this up, all we need to do is take the back off that, disconnect the mic insert, and put our crocodile clips across that. And then, I don't see many of these, you know, I'm probably not going to have to do this again, so making up jigs for nothing, we'll make up this mic, and then we'll have an external mic to play with on the product. Now, it's lost its curl, hasn't it, here? There should be a straight bit, but it's got shorter and shorter, and it's just going to get a bit shorter still, because I'm going to have to cut that off, because I can see that it's got ingress of moisture. So let's hope that this bit hasn't got ingress of moisture. We would never shorten a lead like this for a customer, but for this jig, or for this mic which we're going to use, we can. So we're now on Thursday. I've got a full day of stuff booked. We've got a shopping job to do for one of the elderly church people, and she has me go to Sainsbury's. And considering I tend to shop at Aldi and Lidl, I certainly look at Sainsbury's pricing and think, goodness me. Then, I've got the wrong cutters here. Oh, come on off. Yeah, that should be alright. So, we've got an organ to tune this afternoon, which is about 12 miles away. Normally they have us once a year, but they've got some super big Queen celebration tomorrow on Friday. So what's it, the 2nd today? That's the 3rd then. So they just want it to be spot on. So I could have done without that, but you know, these things happen. We've got that radiogramming bits in the Tango Towers Chapel, and this is the one which has come from London, the HMV Stairmaster 2419, that's been turned into a trinket box. And the woodwork's such high quality, what they've done. It's just such a bizarre thing to do, and we've got to turn it back into a radiogram. We've got to drill out the speaker apertures, which have been beautifully blocked in timber. But Mr. Chippy had an idea, and he started implementing that yesterday evening. So I'm now not worried about that at all, because it looks like we know what we're doing on that. So we've got to put new speakers in because they're missing. Mr. Chippy will be overhauling the chassis, and I'll be overhauling the record deck. And then we've got another one coming in from Austria, believe it or not, on Wednesday next week. And he says he's going to be in this country a couple of weeks. Is it possible to do it in a couple of weeks? I says no, I doubt it, because we don't know what parts it needs until it comes, really. But he'll be here again in 9 months, so I think that's probably when he'll get it back. And that's the first model they did, the 2018 in 1966. I don't think we've ever seen one. I don't think we've ever seen. No, I know we haven't ever seen a customer's one before. I own one. I didn't do a full overhaul. I just got ours working. Now we don't need all these wires. These Tandy microphones fitted earlier models as well with relay switching. So, although I'm kind of preparing all these, I doubt that we're going to be putting them all in. I need to slip that through, and really I need something which is a lubricant, but I tell you what, we'll use the service hole, because whilst that doesn't evaporate, I should be able to just get it through the sleeve. Go on. There we go. It's difficult when you've lost the straight bit. Right, we'll get our little jig. That's what I was going to do. I was going to put a curly lead into one of these type of boxes with a PTT as a toggle switch and a BNC for the audio input. But I thought, no, we'll do it the mic way. Just tin all these. This video is going to be about 2 hours long by the time I've done all this. I could have cleaned some organ pipes instead. Did absolutely nothing to the organ yesterday, and it's, you know, that's the priority here. So we'll just look up on our list. Save me looking it up in the service manual. Realistic is pin out number 6. I'm going to open the other end, just see what colours go where. I really like these mics. The PTT switch is really big, and the plastic pillars which these case screws go through, you'll see, are really well. It's really well mounted. It's big. It's well mounted. And we're going to leave that off because I'm going to access that, aren't I, with my AF generator. Dread to think what that is. I gave it a bit of a clean. So we can see now what we've got. So if the PTT is working in that direction, we know that red is transmit. So we've got to start there, and we know that I'd put some sleeving on this if it was for a customer, but it's for me. So do I have to bother? I don't think the box of sleeving's on this bench anyway. So pin out number 6. TX is, we know, is red. And we know that braid is actually 1 right at the opposite end. Right, so we've got receive. So in transmit we're going over to the red wire, so the braid's connected to the middle, that's our common, and in receive we're going to the black wire. And so the receive on here is pin 5, so the black. Can go into position. So audio, we see the microphone, of course one end of it goes to common, the braid, and the other is switched, and it is white. Transmit audio is in fact the one next to the braid, which in 5-pin DIN speak is pin 4. So remember, the pins are 5 DIN, a 1, 14253 14253 14253, because it started life as mono. Now the blue wire, which we don't need, is kind of audio mute, and I'm going to put that in because I may as well, instead of cutting it off. So it's not used on any of the sets we'll ever see. You never know, this might find its way back to America one day, and there might be a radio there that needs that. Especially if we can get it out of the bundle. So there we go, we've got them all in. Put the jig back. Put the crimpy thing back. And we'll just find, I haven't got any crimps on here, we'll just get some pliers to this. Say this doesn't have to be done brilliantly. Well, that's held in nicely. These are much less fiddly if you've got the straight bit and not into the curl. Hello, being attacked by a mad piece of cardboard. Don't even know where the small screwdriver is. I think the night shift raided the tools on here. There we go. So we've got ourselves a microphone. So all we've got to do is pick the radio back up. Just like that. And we need to work on it that way on. So now we can plug this into the external microphone socket. Just like that. Make sure the test set's on, switch the power on. So if we press the transmit button, let's go for picture in picture. If we press the transmit button on the radio, we no longer have that. Unplug the mic, we still have that. So the mic switches off the local PTT. So let's just test this mic. Press the transmit button, we have transmit. Press the audio button, wallow, we haven't got any audio, but we may not be on frequency because we're on CPT. Mind you, the mic may not work. 1 2 1 2 wallow, 1 2 1 2 wallow, wallow, wallow. You know what, I don't think this mic actually works. One two 1 2 1 2 1 2. I'll just tune the signal. I'll tune the deviation meter with the internal mic, just so we know we've got audio. 1 2 1 2 wallow. as you can see, we've got audio now. So if I plug the external mic in, that mic doesn't actually work, which doesn't matter, because we've just got ourselves a jig, haven't we? 1 2 1 2. So you can see it when I touch the audio hot and generating that hum that we've got audio. So I'm just going to unsolder the mic wire, even though it appears to be open circuit. And now I'm going to go, I'll put this to one side, the meter, and we'll go and get the audio generator. Okay, so we've got ourselves here a dead cheap Chinese audio signal generator. They're about £90. That's dead cheap. What we're going to do is we're going to take this to the signal generator. Sorry, we're going to take this to the frequency counter on my test set. So switch it on. We want 1250. So theoretically, it's going to be so out is sine wave, which is what we want. So 1250 is going to be how come that's got distorted? What's happened there? I've got some mysterious heat. Wow, what's happened there? So 1250 should theoretically be there, and so I expect that is there. So to prove that, I need to just put it into this frequency counter. They went to external time. Correct input. So that's showing 2500. I don't know why that is. Let's alter it. Well, that's about round where we want to be. So we'll now apply that to the radio. Put that kind of at the back out of the way if I can. And we'll apply this to there we go. So having done that, let's see what the service manual says we've got to do. I'm just remembering what it said yesterday, but I've got a memory like a sieve. So it wants it at 2 millivolts. So we need to measure that with our true RMS meter. Right, we've got 2.4 millivolts, we've got 1250 kilohertz. So now when I press transfer, I'll put my monitor receiver on so you can hear it. So now all we need to do is to get the other meter back, and at test point 2 adjust variable resistance 2 for 2.5 volts. I'll have to move the camera down so it probably photographs my knee instead. Not that one. Can't move the radio, I have to move the camera. So back to finding the test point. test point, we've now got this upside down. So test point 2 is that transistor. Yeah, it's there. So how on earth you adjust that at the same time is anybody's guess. If you're doing this in a factory situation, you'd all be set up to do this. So I'll tell you what, now we've done that, we'll turn it back the other way. Put that back on. Press transmit. And hopefully we can now adjust VR2. So I'll just kind of bring the meter into shot, and now I've lost the display. It wasn't there. So we have 2.5 volts on that meter. So now we should be able to move forwards and do the deviation. What a fact. So now we want the 1 kilohertz deviation. So we'll disconnect our tone generator externally. We'll have to disconnect our external mic because the microphone doesn't actually work, and we'll bring our normal little oscillator into play and put the 1 kilohertz tone on. Put that where the mic is. Press the VTT on the radio, and lo and behold, oh, I'll show you the meter. Press transmit, and we've got, voila, that's too loud. I can see as I speak that's going up to 4.5. So we now need to adjust VR1 for 1 kilohertz deviation. Voila, 1, 2, and then your voice should come into the 2.2 to 2.5 range. Voila, 1, 2, voila, and it does. So the procedure has worked. What a faff. I've never seen anything like that. Okay, so we'll put loads of extra equipment away again. What's that taken? 3/4 of an hour to do the deviation. Right, I'm back with you after that shopping job. It's 11:15 in the morning, and it is still Thursday. So, having done the transmit, unless there's something I've missed, so that deviation is an absolute faff. Now we know this is a new set. I've owned it from new. I didn't need to do that VR2. I could have just adjusted VR1 had it needed it, but this is part of the demonstration. So it's a complex thing to do. So there's nothing else to do, nothing to adjust. So we now move on to the receiver. So we're on CPT, so channel 20 is 27205. Let's put the power back on. So with the signal generator connected, we want 27205. And we have 27205 on the signal generator. So I'll switch my oscilloscope on, and we're going to set the detector first. In fact, that's exactly what they tell you to do. So set the signal generator. Oh, we're not doing 400 because we're using a synod meter. We don't need to do that. So they're doing it a different way. Signal generator, radio, AC electronic voltmeter, oscilloscope distortion meter, and 8 ohm dummy load. Well, we've got the dummy load in the test set. We've got the oscilloscope. Instead of distortion meter, we're using synod meter. So here goes. Let's put the oscilloscope on the screen, and we'll turn the bench light off so we can actually see it. So it says it's T4. So if we go back, so I don't have to look, T4 is the one just there. So while we've got that open, we're going to be doing T1, 2, 3 and 4. So T1, 2, 3, 4. 1, 2, 3, 4. We're starting with 4. So on an S9 signal on, and this radio has to have a signal meter, which is a bit unusual for a realistic. And we're going to need to plug into the extension speaker socket, which is sensibly provided on a set of this quality. There we go. Just turn up the volume enough to get the trace we're looking for, and adjust T4 for maximum recovered audio. And of course it was spot on, because it may be 30 years old, but it's had much use. So we need to do 2, 3 and 4. So now we're going to go over to the synod meter, and we'll switch till we get 4 dBs. There we are. It's adjusted the attenuator. That is 0.49 of a microvolt. Let's see what that is. It is doing currently just over 1 microvolt. Let's give an accurate figure. So at the moment it's doing 1.05 microvolts for 12 dB synod. So does it tell us what it's supposed to do? Ah, it's 10 dB synod, the reference. It's doing... I have to change scales now. Always between scales. It's doing 0.89 microvolts for 10 dB synod, and it's supposed to. They'd like it to do 0.5, and your limit spec is 1, so it's well within the limit spec. Let's see whether we can make it better. That sounds like a doctor speaking, doesn't it? Dr. Tango, we'll see you now. My dad was a doctor of chemistry. Probably how he came by having me. So that's optimum there. No, there's not going to be any change. So let's go back to 10 dB. 0.8 microvolts. So we've gained a tiny little bit. It's absolutely fine. It's well in spec. So that's that done. Change the page. That's it. We're done. So yeah, that preset was the power. Yeah, we're done. Radius crystal filtered. So I take it there's no squelch preset. There's no mention of setting up the squelch at all, but we're going to check the squelch. So put the radio to full squelch. and the signal generator. Let's put these camera onto the attenuator controls. At the moment we're at 1 microvolt, so I'd like this radio to be 100 microvolts for a full for the squelch to open. 1, 3, 10, 30. Comes in at 30. Let's give an accurate reading for you. It comes in fact at 20 microvolts, so it's a bit wishy-washy, but it's a handheld. And let's see where the sensitivity is at the other end. So we're going to, I've parked the signal generator at 0.3 of a microvolt, which is what you can hear. In fact, we can hear it right down to 0.2 of a microvolt. Switch the signal generator to standby, turn the squelch for threshold, switch the signal generator back on, and you look, wow, it's straight in at 0.3. Yeah, it's coming in at 0.3 and it's leaving about 0.19. So really, really good squelch in the sensitivity side of it. If you use this set as a base station, which you can do because you've the ability to plug in external mic, external aerial, etc., you may find the squelch inadequate. Depends what kind of usage area you're in. So all that difficulty doing the deviation VR2 and the rest of it has been pretty easy. So now I've got to do is to try and, oh, just out of interest, I was going to say try and put it back together. Let's see where this signal meter is. So for 100 microvolts it's reading 4 bars, and if we go up from there it reads 5 bars. So if you said 4 bars was S9, I don't know if the case says anything like that. No, it doesn't. Now this microphone's constantly trying to fall out of there, so I don't know what we're going to do about that. Probably put a dab of adhesive, I think. And that's just a dot on one edge. So I'll switch it off and disconnect the aerial, disconnect the extension speaker, and now we've got the fun of starting to put it back together. Right, so it slides down. Simple as that, slides down. Let's get that crud out of there. We've made sure we've got those still in place. And now we have to screw it all back together. And put the aerial in. Now I've forgotten which screws went where, so hopefully the service manual will helpfully say. You've got 6mm and 10mm. $23 for the shorter ones, $24 for the longer ones. So one of the longer ones is there and there. So that's all the screws back. 10mm, 10mm, 6mm, 6mm. So we need the antenna. Thread that through the grommet. and it's the 6mm countersunk one that goes in there. I'm having difficulty gripping the antenna. Good. That was the most difficult part. And then the back goes on. And we've got to make sure these cover goes in. So clip in that. Yes, that's all there. We've got the machine screw goes there. Self tapper there. Self tapper there. Wrong screwdriver. That one. Lost the range boost side panels on these sets, which is such a shame. If they just put metal pads on and earth them, it'd make all the difference to range. It isn't a gimmick, it really does work. Okay, so we just need to put the two bottom screws in. And Bob's your uncle, as they say. So the transmit easily exceeded spec, and the receive is within the spec. So there we are. Just going to look at this microphone just before we go any further. I suspect the microphone insert is open circuit. So we'll just check that. Check for continuity. Yep. Now, just in case it's a dry joint, it's just possible. It just could be possible. But you know, you don't know whether this set's been outside in a damp shed, whether it's been in a bucket of water. You don't know I don't know the origin. It's come in a box of junk, and junk is what it may well be. So once again, we'll just check it. No, the insert is open circuit. So we'll screw it back together, because you never know, another scrap one may come up, and we may be able to get this working. They are nice microphones. Right, time to put it on the air. We'll switch the soldering iron off, save even more electricity. Now, I never get anybody on UK channels, so the chances of getting anybody on CEPT channels is 1,000,000 to 1, I'm sure. But nevertheless, we will plug it in. CEPT tends to be full of what I would regard as foreign interference. Doesn't work for me. Sometimes we get as little as half a mile range because of that. So, here we go. A Roger. One for a Roger. SSB rubbish, SSB rubbish, SSB rubbish. There's a lot of noise you see there. Anyway, there you have it. We'll do a on the air test, and we'll see how we get on with that with Mr. Chippy. It'd be nice to have got the external mic, but that wasn't to be. So, I've gone into a lot of detail of that. I've done that first VR2 adjustment for the deviation was totally necessary, but the demonstration was to show what has to be done if it's been messed about with. Most of the time, I think if the deviation needs changing, it would just be the VR1. Thanks for watching the realistic TRC1010 from 1991.